I'm learning a course on Coursera which is machine learning for product managers, and as part of that, this is my course project submission. Before going into the submission, I'd like to reiterate the problem. So in this, we have to build a model to predict the energy output of a combined cycle power plant. We have been given data for multiple features, the features being temperature, ambient pressure, relative humidity, exhaust, vacuum. And basically, we'll have to predict the net hourly electrical energy output, which is PE, right? So the first factor is what type of machine learning approach is needed here. So I looked at the data for all these features, and these are continuous data, which is temperature, pressure, humidity, and vacuum. Right. So based on that, I am selecting linear regression, and I'll be using Excel. We could also use random forest here, but since I'm limited to Excel, I'll use the linear regression model here. Uh, for the output matrix, I'll use the mean squared error and the mean absolute error. Mean squared error because it's the most popular regression error metric, and MAE as it can be easier to interpret, right? Since I am again doing this in Excel, my validation approach is that I'll use the same algorithm, which is linear regression, and I'll use a combination of features to see the variation in terms of output matrix. I did split my data between 60% training, 20% validation, and 20% test. So moving to case one, where I've considered all the features, right? I just wanted to see what happens if I use all the features. So when I do the linear regression on my training data, I see a good R square value in this, which is closer to 1. So basically, it gives me an idea that if we use all four of them, this looks to be quite good from an initial interpretation. Then what I did to check multiple combinations, I removed one of the features and again run the linear regression. And I repeated this for when I removed pressure, vacuum, and temperature, right? So I'll quickly switch over to the Excel sheet where I did this. So this is the whole input data, right? And this is when I ran it from all the features, and then basically when I started removing features, what exactly happened is given here. So if we see when we use all the features together, right, get a good adjusted R square. The mean square value of 20.94 is also the lowest across all the features, and the mean absolute error is also lowest. So this seems to be a good combination of, basically if we use all the four features, we get uh, um, good mean square error, mean absolute error, which means our the predictability of our algorithm is quite good. Now if you focus on the other features where I had reduced one of the features, right? Whenever I'm using atmospheric uh, temperature, I am still getting a good adjusted R square value, mean squared error, and mean absolute error values. However, the moment I sort of remove this, the the mean squared error value and the mean absolute error value spikes quite a lot, which indicates that basically this feature is something we should definitely use in this algorithm, and it gives us sort of better predictability. So that's my submission. Please review it. Thank you.